Namaskar students. Hope you are hale and hearty, taking care of your health and your studies. My name is Jyotsna and I am from Education Department, Chandigarh. Have you ever thought why we call Mother Nature a mother? Because it just gives us and never expects anything from us. We extract, we exploit it to its core. Yes, by that I mean extracting the minerals from Mother Earth. You know, it is aptly said that nature gives us free lunches, but we must know how to control our appetites. That's what this session is going to be all about today. We are going to take up chapter number 5, Minerals and Energy Resources of grade 10. The name of the book is Contemporary India Part 2. So, without wasting any time, let's get going. We use different things in our daily life made from metal. Can you list a number of items used in your house made of metal? Where do these metals come from? You have studied that the Earth's crust is made up of different minerals embedded in the rock. Various metals are extracted from these minerals after proper refinement. Minerals are an indispensable part of our lives. Almost everything we use, from a tiny pin to a towering building or a big ship, like a toothpaste. Toothpaste cleans your teeth. Abrasive minerals like silica, limestone, aluminium oxide, and various phosphate minerals do the cleaning. Fluoride, which is used to reduce cavities, comes from a mineral fluorite. Most toothpaste are made white with titanium oxide, which comes from minerals called rutile, ilmenite, and anatase. The sparkle in some toothpaste come from mica. The toothbrush and tube containing the paste are made up of plastic from petroleum. Now, where are these minerals found? Before that, let's take up what is a mineral. Geologists define mineral as a homogeneous, naturally occurring substance with a definable internal structure. Minerals are found in varied forms in nature, ranging from the hardest diamond to the softest talc. You've already learned about rocks. Rocks are combinations of homogeneous substances called minerals. Some rocks, for instance, limestone, consists of single mineral only, but majority of rock consists of several minerals in varying proportions. Although over 2000 minerals have been identified, only a few are abundantly found in most of the rocks. A particular mineral that will be formed from a certain combination of elements depends upon the physical and chemical condition under which the material forms. This in turn results in a wide range of colors, hardness, crystal forms, luster, and density that a particular mineral possesses. Geologists use these properties to classify the minerals. Now, how these minerals occur? Let's take up the mode of occurrence of these minerals. So, where are these minerals found? Minerals are usually found in ores, that we know. However, for general and commercial purpose, minerals can be classified as per the table given on the screens. Out here we can see that minerals are broadly categorized into metallic, non-metallic, and energy minerals. Metallic is further divided into ferrous, non-ferrous, and precious. First of all, let's take up metallic. Metallic minerals are the ones which contain iron to it. For example, iron ore, manganese, nickel, cobalt, etc. For the non-ferrous are those which does not contain iron to it, like copper, lead, tin, bauxite, etc. The third part of metallic mineral is precious minerals like gold, silver, platinum. Under non-metallic, we have mica, salt, potash, sulfur, granite, limestone, marble, and sandstone. For the energy minerals, we have coal, petroleum, and natural gas. So, let's take up where minerals generally occur. Minerals generally occur in these forms. Minerals are usually found in ores, as we discussed earlier. The term ore is used to describe an accumulation of any mineral mixed with other elements. The mineral content of the ore must be in sufficient concentration to make its extraction commercially viable. The type of formation or structure in which they are found determines the relative ease with which mineral ores may be mined. This also determines the cost of extraction. It is therefore important for us to understand the main type of formations in which minerals occur. Like in igneous and metamorphic rocks, minerals may occur in the cracks, faults, or joints. The smaller occurrences are called veins, and the larger ones are called lodes. In most cases, they are formed when minerals in liquid, molten, and gaseous forms are forced upward through cavities toward the Earth's surface. They cool and solidify as they rise. Major metallic minerals like tin, copper, zinc, and lead are obtained from veins and lodes. In sedimentary rocks, a number of minerals occur in beds or layers. They have been formed as a result of deposition, accumulation, and concentration in horizontal strata. Coal and some forms of iron ore have been concentrated as a result of long periods under great heat and pressure. Another group of sedimentary minerals include gypsum, potash salt, and sodium salt. These are formed as a result of evaporation, especially in arid regions. Another mode of formation involves the decomposition of surface rocks and the removal of soluble constituents, leaving a residual mass of a weathered material containing ores. Bauxite is formed this way. Certain minerals may occur as alluvial deposits in sands of valley floors and the base of hills. These deposits are called placer deposits and generally contain minerals which are not corroded by water, like gold, silver, tin, and platinum are most important among such minerals. The ocean waters contain vast quantities of minerals, but most of these are too widely diffused to be of economic significance. However, common salt, magnesium, and bromine are largely derived from ocean waters. The ocean beds too are rich in manganese nodules. Now let's begin with ferrous minerals. Ferrous minerals account for about 3/4 of total value of the production of metallic minerals. They provide a strong base for the development of metallurgical industries. India exports substantial quantities of ferrous minerals after meeting her internal demands. First and foremost is iron ore. Iron ore is the basic mineral and the backbone of industrial development. India is endowed with fairly abundant resources of iron ore. India is rich in good quality iron ores. Magnetite is the finest iron ore with a very high content of iron up to 70%. It has excellent magnetic qualities, especially valuable in the electrical industry. Hematite ore is the most important industrial iron ore in terms of quantity used, but has a slightly lower iron content than magnetite. The major iron ore belts in India are Odisha, Jharkhand belt. In Odisha, high-grade hematite ore is found in Badampahar mines in Mayurbhanj and Kendujhar districts. In the adjoining Singhbhum district of Jharkhand, hematite iron ore is mined in Goa and Noamandi. Durg, Bastar, Chandrapur belt lies in the Chhattisgarh and Maharashtra. Very high-grade hematites are found in the famous Bailadila range of hills in the Bastar district of Chhattisgarh. The range of hills comprise of 14 deposits of super high-grade hematite iron ore. It has the best physical properties needed for steel making. Iron ore from these mines is exported to Japan and South Korea via Vishakhapatnam port. Next is Ballari, Chitradurga, Chikmagaluru, Tumakuru belt in Karnataka. It has large reserves of iron ore. The Kudermukh mines located in the western Ghats of Karnataka are a 100% export unit. Kudremukh deposits are known to be one of the largest in the world. The ore is transported as slurry through a pipeline to a port near Mangaluru. Maharashtra-Goa belt includes the state of Goa and Ratnagiri district of Maharashtra. Though the ores are not of very high quality, yet they are efficiently exploited. Iron ore is exported through Marmagao port. Next is manganese. Manganese is mainly used in the manufacturing of steel and ferromanganese alloy. Nearly 10 kg of manganese is required to manufacture 1 ton of steel. It is also used in manufacturing bleaching powder, insecticides and paints. From ferrous, now let's move to non-ferrous minerals. India's reserves and productions of non-ferrous mineral is not very satisfactory. However, these minerals, which include copper, bauxite, lead, zinc and gold, play a vital role in a number of metallurgical, engineering and electrical industries. Let us study the distribution of copper and bauxite. Starting with copper, India is critically deficient in reserves and production of copper. Being malleable, ductile and a good conductor, copper is mainly used in electrical cables, electronics and chemical industries. The Balaghat mines in Madhya Pradesh, Khetri mines in Rajasthan and the Singamam district of Jharkhand are leading producers of copper. From copper, let's shift to bauxite. Though several ores contain aluminium, it is from bauxite, a clay-like substance, that alumina and later aluminium is obtained. Bauxite deposits are formed by decomposition of a varied variety of rocks rich in aluminium silicates. Aluminium is an important metal because it combines the strength of metals such as iron with extreme lightness and also with good conductivity and great malleability. India's bauxite deposits are mainly found in the Amarkantak Plateau, Maikal Hills and the plateau region of Bilaspur, Katni. Odisha was the largest bauxite producing state in India in 2016-17. Panchpat Mali deposits in Koraput district are the most important bauxite deposits in the state. Now talking about the non-metallic minerals. Mica is a mineral made up of series of plates or leaves. It splits easily into thin sheets. These sheets can be so thin that 1,000 can be layered into a mica sheet of a few centimeters high. Mica can be clear, black, green, red, yellow or brown. Due to its excellent dielectric strength, low power loss factor, insulating properties and resistance to high voltage, mica is one of the most indispensable minerals used in electric and electronic industries. Mica deposits are found in the northern edge of Chota Nagpur Plateau, Koderma, Gaya. Hazaribagh belt of Jharkhand is the leading producer of mica. In Rajasthan, the major mica producing area is around Ajmer. Nellore mica belt of Andhra Pradesh is also an important producer in the country. Let's shift our focus to rock minerals now. Now, limestone is found in association with rocks composed of calcium carbonates or calcium and magnesium carbonates. It is found in sedimentary rocks of most geological formations. Limestone is the basic raw material for the cement industry and essential for smelting iron ore in the blast furnace. Now let's take up conservation of minerals. We all appreciate the strong dependence of industry and agriculture upon mineral deposits and the substances manufactured from them. The total volume of workable mineral deposit is an insignificant fraction, 1% of Earth's crust. We are rapidly consuming mineral resources that required millions of years to be created and concentrated. The geological processes of mineral formation are so slow that the rates of replenishment are infinitely small in comparison to the present rates of consumption. Mineral resources are therefore finite and non-renewable. Rich mineral deposits are our country's extremely valuable but short-lived possessions. Continued extraction of ores leads to increasing costs as mineral extraction comes from greater depths along with decrease in quality. A concerted effort has to be made in order to use our mineral resources in a planned and sustainable manner. Improved technologies need to be constantly evolved to allow use of a low-grade ores at low cost. Recycling of metals, using scrap metals and other substitutes are steps in conserving our mineral resources for the future. Talking about energy resources, energy is required for all activities. It is needed to cook, to provide light and heat, to propel vehicles and to drive machinery in industries. Energy can be generated from fuel, minerals like coal, petroleum, natural gas, uranium, and from electricity. Energy resources can be classified as conventional and non-conventional sources. Conventional sources include firewood, kettle dung cake, coal, petroleum, natural gas, and electricity. Non-conventional sources include solar, wind, tidal, geothermal, biogas, and atomic energy. Firewood and kettle dung cake are most common in rural India. Talking about conventional sources of energy, let's take up coal. In India, coal is most abundantly available fossil fuel. It provides a substantial part of the nation's energy needs. It is used for power generation to supply energy to industry as well as for domestic needs. India is highly dependent on coal for meeting its commercial energy requirements. As you are clear, coal is formed due to compression of plant material over millions of years. Coal, therefore, is found in a variety of forms depending on the degrees of compression and the depth and time of burial. Decaying plants in swamps produce peat, which has a low carbon and high moisture content and low heating capacity. Lignite is a low-grade brown coal, which is soft with high moisture content. The principal lignite reserves are in Neyveli in Tamil Nadu and are used for generation of electricity. Coal that has been buried deep and subjected to increased temperatures is bituminous coal. It is most popular coal in commercial use. Metallurgical coal is high-grade bituminous coal, which has a special value for smelting iron in blast furnaces. Anthracite is the highest quality hard coal. In India, coal occurs in rock series of two main geological ages, namely Gondwana, a little over 200 million years in age, and in tertiary deposits which are only about 55 million years old. The major resources of Gondwana coal, which are metallurgical coal, are located in Damodar Valley in West Bengal, Jharkhand. Jharia, Raniganj, Bokaro are important coal fields. The Godavari, Mahanadi, Son and Wardha valleys also contain coal deposits. Tertiary coal occurs in northeastern states of Meghalaya, Assam, Arunachal Pradesh and Nagaland. Talking about petroleum. Petroleum or mineral oil is the next major energy source in India after coal. It provides fuel for heat and lighting, lubricants for machinery and raw material for a number of manufacturing industries. Petroleum refineries act as a nodal industry for synthetic, textile, fertilizer and numerous chemical industries. Most of the petroleum occurrences in India are associated with anticlines and fault traps in rock formation of tertiary age. Mumbai High, Gujarat and Assam are major petroleum production areas in India. Now let's talk about natural gas. Natural gas is an important clean energy resource found in association with or without petroleum. It is used as a source of energy as well as an industrial raw material in the petrochemical industry. Natural gas is considered an environment-friendly fuel because of low carbon dioxide emission, and it is therefore the fuel for the present century. Large reserves of natural gas have been discovered in the Krishna-Godavari basin. Along the west coast, the reserves of the Mumbai High and allied fields are supplemented by finds in the Gulf of Cambay. Andaman and Nicobar Islands are also important areas having large reserves of natural gas. Use of compressed natural gas or CNG for vehicles to replace liquid fuel is gaining wide popularity in our country. From here, now let's discuss electricity. Electricity has such a wide range of applications in today's world that its per capita consumption is considered as an index of development. Electricity is generated mainly in two ways: by running water, which drives hydro turbines to generate hydroelectricity, and by burning other fuels such as coal, petroleum and natural gas to drive turbines to produce thermal power. once generated, the electricity is exactly the same. Hydroelectricity is generated by fast flowing water, which is renewable resource. India has a number of multi-purpose projects like Bhakra Nangal, Damodar Valley Corporation, the Kopili Hydel project, etc., producing hydroelectric power. Thermal electricity is generated by using coal, petroleum and natural gas. As we discussed earlier, the thermal power stations use non-renewable fossil fuels for generating electricity. Now let's talk about some non-conventional sources of energy. First and foremost, we have nuclear or atomic energy. It is obtained by altering the structure of atoms. When such an alteration is made, much energy is released in form of heat, and this is used to generate electric power. Uranium and thorium, which are available in Jharkhand and the Aravalli range of Rajasthan, are used for generating atomic or nuclear power. The monzite sands of Kerala is also rich in thorium. From nuclear, let's talk about solar energy. India is a tropical country. It has enormous possibilities of tapping solar energy. Photovoltaic technology converts sunlight directly into electricity. Solar energy is fast becoming popular in rural and remote areas. Some big solar power plants are being established in different parts of India, which will minimize the dependence of rural households on firewood and dung cakes, which in turn will contribute to environmental conservation and adequate supply of manure in agriculture. Wind power. India has great potential of wind power. The largest wind farm cluster is located in Tamil Nadu, from Nagarcoil to Madurai. Apart from these, Andhra Pradesh, Karnataka, Gujarat, Kerala, Maharashtra and Lakshadweep have important wind farms. Nagarcoil and Jaisalmer are well known for effective use of wind energy in the country. Biogas, shrubs, farm waste, animal and human waste are used to produce biogas for domestic consumption in rural areas. Decomposition of organic matter yields gas, which has higher thermal efficiency in comparison to kerosene or dung cake and charcoal. Biogas plants are set up at municipal, cooperative and individual levels. The plants using cattle dung are known as gobar gas plants in rural areas. These provide twin benefits to the farmer in form of energy and improved quality of manure. Biogas is by far the most efficient use of cattle dung. It improves the quality of manure and also prevents the loss of trees and manure due to burning of fuel wood and cow dung cakes. Tidal energy. Oceanic tides can be used to generate electricity. Floodgate dams are built across inlets. During high tide, water flows into the inlet and gets trapped. When the gate is closed, after the tide falls outside the floodgate, the water retained by the floodgate flows back to the sea via a pipe that carries it through a power generating turbine. In India, the Gulf of Khambat, the Gulf of Kutch in Gujarat on western coast and Gangetic Delta in Sundarbans region of West Bengal provide ideal conditions for utilizing tidal energy. Geothermal energy. Geothermal energy refers to the heat and electricity produced by using the heat from the interior of the earth. Geothermal energy exists because the earth grows progressively hotter with increasing depth. Where the geothermal gradient is high, high temperatures are found at shallow depths. Groundwater in such areas absorbs heat from rocks and becomes hot. It is so hot that when it rises to Earth's surface, it turns into steam. This steam is used to drive turbines and generate electricity. There are several hundred hot springs in India, which could be used to generate electricity. 2 experimental projects have been set up in India to harness geothermal energy. One is located in Parvati Valley near Manikaran in Himachal Pradesh and the other is located in Puga Valley, Ladakh. Conservation of energy resources. Energy is a basic requirement for economic development. Every sector of the national economy, agriculture, industry, transport, commercial and domestic needs input of energy. The economic development plans implemented since independence necessarily required increasing amount of energy to remain operational. As a result, consumption of energy in all forms has been steadily rising all over the country. In this background, there is an urgent need to develop a sustainable path of energy development. Promotion of energy conservation and increased use of renewable energy resources are the twin planks of sustainable energy. India is presently one of the least energy efficient countries in the world. We have to adopt a cautious approach for the judicious use of our limited energy resources. For example, as concerned citizens, we can do our bit by using public transport system instead of individual vehicles, switching off electricity when not in use, using power saving devices, and using non-conventional sources of energy. After all, energy saved is energy produced. I'm sure it must have been a very fruitful experience today. Let's try to analyze what you have extracted out of today's session. On your screens, you can see certain statements or questions. Along with that, you have 4 options. You have to pick the correct option. So, without wasting any time, let's get started. Which one of the following makes our toothpaste white? Fluorine, titanium oxide, limestone, or phosphate? The correct option is titanium oxide. Toothbrush and toothpaste tube are made of limestone, phosphate, petroleum, or silica. Correct option is petroleum. From which of the following do minerals come from? Core, crust, mantle, or none of these? The correct option is crust. Limestone is found in which rock? Igneous, sedimentary, metamorphic, or none of these? Correct answer is sedimentary. Moving on, which one of the following minerals is formed due to evaporation? Chalk, silica, petroleum, or gypsum? Yes, the correct answer is gypsum. Which one of the following mineral is obtained from bauxite? Iron, aluminium, copper, or mica? The correct answer is aluminium. The earth, air, and water are not a gift to us from our parents, but a loan from our children. We must hand over a better world to them, and we must make energy conservation a habit. Together we can and we will make a difference. We'll be back with many more videos. Till then, stay safe, stay healthy, and keep learning. Namaskar.